Okay, Melanie, you are good at reading very fast, so maybe you can assist us. So I'm always struck with the first and second question. It's too hard.
Right. Okay, give me 1 second to open it up because I'm having a hard time. Hang on.
Okay.
I'm almost there. It's getting there, slow but sure.
Yes. We are almost there.
Okay. Question 1. Given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept?
Y-intercept is 2.0. Did you notice that?
How is that? Because don't you have to...
So when you look at even the question, it does okay. Y equal to 2.0 plus 1.5x, and when we put that into the equation, we know that the 2.0 becomes the y-intercept.
I don't think so. I think yeah, no, well, maybe. Yeah, I guess so. Okay. Round to 1 decimal.
Yeah.
Okay, given the linear regression equation, y equals 2.0 plus 1.5x, what is the slope?
So in this case, the slope will be the 1.5.
Yes. Yeah.
Given the linear regression equation, y equals negative 3.0 plus 0.25x, what is the predicted value of y when x equals 16?
So you just plug in the 16 multiplied by the 0.25, add to minus 3. So that should be 1.0, right?
Yeah.
Yes. 1.0.
Hang on 1 second. It's 1.
0.0.
4. Okay. Okay, so we need to use the math efficiency thingy, major. And the confidence data. What's the confidence data?
That is a math.
Is there a spreadsheet?
Yeah, I think that should be the quantitative inference procedures that we're using, right? So because we are dealing with linear regression.
Okay. All right, so the question is make a scatter plot of the math efficiency data of the three data shapes. Three data shapes introduced in the reading. Which shape best describes these data?
Okay. So
Hot dog shape.
Yeah, that's what I was thinking.
Everybody
so
agree?
yeah, that is the hot dog shape.
Yeah. All right. Simple linear regression is Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data?
So that would be simple linear regression is appropriate for this data, the first one.
What?
Yeah.
Explain simple linear regression to me. Can you explain that to me? Simple linear regression, just in simple words, not in the textbook words.
Joshua, can you have any way to explain it? So when we take a linear regression, basically what we are trying to do is to be able to fit a data into the line, whereby we can be able to find which variable is independent and which one is dependent on the other variable. So,
I see where it's at.
so based on that, we can be able to find if, like you are plotting a simple linear regression, you'll be able to find which one belongs to y intercept, which one also belongs to the x intercept, and then you, based on the available information given to you, you should be able to find the various variables that are independent or dependent on each other.
So basically, correct me if I'm wrong. In the other lessons, it's like it asks the question a lot: is it have the things been met, the requirements been met? Is that basically the same idea?
Yes, this one to still there should be a requirement that should be made. So it's based on the same principles that we're using in a previous assignment.
So that's okay. That's fine. Thank you. Moving on. Sorry about that.
Oh no, you're fine.
How many observations are in the data? No. does that mean? Anybody?
I think that is the sample size.
Oh, hi, Stephen.
Oh, hello everyone. Sorry. So I think that is the sample size. So it's 139. 139.
Yes.
That's what
Yes.
I thought.
That is what I also.
Okay.
Yes.
What is the y-intercept? There's a lot of numbers there.
Oh yeah, I think there is a cell H13. I don't know if you can see that. 18.6990.
Yeah.
What?
Yeah.
18?
In the cell H13.
I got 1.296 there.
One.
That's the y-intercept B with the parentheses BO
Yeah.
under the B coefficient.
Yeah. What did you get?
1.296.
I don't know what. Um,
What did
Can
I
you
do?
share your screen?
Yeah. Let me see. Hang on. Hang on. Can you guys see that? Probably not.
I think maybe you. How do you? Which data did you put in first?
I just copied it the way it was. Did I do it backwards?
maybe you need to switch the
Yeah.
columns.
You need to switch the columns.
Oh, look at there. Okay.
Yeah, got it.
Did you get it now?
Yes.
Okay. Yeah. So next time when you are working on, you just have to be mindful to know which one. I think in the question is. Let me.
It doesn't even specify, I don't think.
Yeah.
Oh, sorry. We are in question what? 9?
Well, we're trying to figure. It doesn't specify which one's the X and which one's the Y in the question. So, all right. This.
And the question says that the confidence is gonna be the explanatory variable, so it's X, and score as the response variable.
Yes.
So it's Y.
So how do you know which is which?
Um.
On the data one, how do you know? Oh, I see. Never mind.
X, X comes first.
I see it.
Yes.
Confidence. Okay. I got you. Okay. All right. What is the slope?
4.695. Did you get it? 12.695.
Yes.
Yes.
What is the predicted value of y when x equals 4?
Okay.
Um,
Yeah, in the cell G18, if you set the value of x, you can have
Yeah.
the predicted value for y.
So that is 69.469.
Yes.
I see. Good. Okay.
Have you seen it, Melanie?
I'm sorry?
Have you seen it?
Yeah, no, I saw it. So you can change that variable
Yes.
x. Yeah.
Yes.
Okay. All right, number 12. The confidence data resulted from students evaluating their confidence for each question on a scale from 1 to 6. What is the maximum predicted value of y for these values of x? I don't even know what that means.
The maximum confidence, I think, is gonna be 6. Is the greatest data for confidence. So if we said x equals 6, we got 94.859. I don't know if I'm right.
Yeah. That is what I got to.
Because the question said, what is the maximum predicted value for y if for these values of x? So the maximum value for x is 6, right?
Yes.
Okay.
Yeah, because it goes down for each one. Yeah.
So it's 94.859.
Yes.
Yeah.
Nice.
So we put that number in, not 6, huh?
Yes.
Okay. How many explanatory variables are present in simple linear regression?
1.
1.
Yeah, 1.
How many response variables are present in simple linear regression?
1.
1.
1.
Okay. A company in South Dakota manufactures hard hats used in the mining industry. The record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include the hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable?
The size of the hat because it's the variable being predicted.
Yes.
Yeah.
First one.
Uh,
Yeah.
okay, I didn't get that one, but all right.
You didn't get which
I
one?
just don't understand why it's that one. I mean, I see that predict the size of the hat, but where is it saying the variable's given? It's saying it's giving the circumference. It doesn't matter.
Yeah, I think that there are many variables. Yeah, you have the hat size, circumference of the hat, and the length of the major and minor axis. But the company wants to predict the size, so
Yeah.
the independent value are the hat size, the circumference of the hat, and the length. And the dependent value is what you want to predict.
Yeah.
So the question is, what is the response variable? So what is the dependent variable?
Okay.
So it's the size of the hat. So what do you want to predict?
Okay. Cool. All right, all done.
Yeah.